the whole time?
Yeah, I can drive for you, Pete. Absolutely.
Great.
All right. So, yeah. Hello. Good afternoon, everyone. Thank you to Anna and everyone else at the Neponset River Watershed Association for giving us this opportunity to present to you all our project and discuss the progress we've made so far. As I mentioned before, I'm Laura Harrington. I'm a physical scientist and GIS specialist with the USGS. Additionally, of course, my partner in crime here, Pete Steves, who is very much our Streamstats guru here. He is also a physical scientist and GIS specialist with the USGS. We are a part of the New England Water Science Center and are stationed in Northern Massachusetts, as I mentioned before. What we will discuss today are efforts in delineating high-resolution urban flow network and drainage areas for stormwater management in the Neponset River Watershed. We are completing this work in partnership with the EPA Region 1. I do want to mention right off the bat that this information in our presentation, and particularly what you see as screen captures, are development versions of Streamstats applications. So they are preliminary, they are subject to revision, and we are right now just providing it to share timely best science. So just keep that in mind as we move forward through the presentation. So getting into it, today we'll provide you with a brief introduction about the project in Streamstats, followed by touching upon some of our methods, various challenges that we might encounter, and we'll provide you with information about our pilot area and a short narrated video describing and demonstrating the application. From there, we'll dive into where we are within the project and where we are going. We will show you how to access the application itself and hopefully leave ample time for some questions, comments, and open discussion with you all. So before we fully dive in, Pete and I just want to thank you for sharing with us your hard-earned data. With your data, you have helped us better understand the hydrology of your town and the surrounding landscape at large. This local knowledge has been really invaluable to us in helping us solve some of the hydraulic puzzles that are out there and aiding us in making really the best model that we can. Without your data, this project would not have been as possible. So we're very much appreciative. So, as we know somewhat, both the natural environment and man-made infrastructure have to be considered when characterizing hydrology and the quality of urban watersheds. So this, of course, is important for stormwater management, which must account for how water flows above ground as well as underground through the stormwater infrastructure. So with this project, we are expanding our Streamstats application to include the Neponset River Watershed. So as you'll see with our demonstration later, the Streamstats application, with the inclusion of the stormwater infrastructure, will output just a more realistic drainage area delineation that is more reflective of that combination between natural environment and infrastructure, hydrology interaction, that sort of thing. And this, in addition to the derivation, the tool can compute land use and land cover basin characteristics for that specific delineation. As you can see, there's a QR code here. If you scan that, that'll bring you to our specific project website for a little bit more information, as well as some contact information. In addition, all of these links will be provided to you via Anna's in the chat. So we'll have some live links in addition to those QR codes. So Streamstats is a geospatial web app available to the public, which allows users to, again, delineate basins, compute basin characteristics, and estimate flow statistics. These functions have been available for around 20 years or so. This image right here will show you another topographic delineation, and the highlights are the options to retrieve, basin characteristics, and estimate flow statistics. Massachusetts has many basic basin characteristics available, including data for length of roads and the number of road and stream interactions. Just to note, for this portion of Streamstats, which is the urban portion, the flow statistics will be a later addition. For the moment, we just don't have that functionality yet, but that's something we hope to add in later once all those kinks have been worked out. So, as mentioned, we are adding that municipal storm drain data to the Streamstats application for the Neponset. This has been previously accomplished for the Mystic Watershed, and those finalized results are available on Streamstats. So as you can see, this screen capture to the left is showing a topographic delineation within our pilot area. On the right, you can see a delineation from approximately the same point of interest, but this time the delineation accounts for those municipal storm drain data. The updated version includes, those pipes, outlet, inlet features. Those are in orange, and those little boxes are the inlets and outlets. So you can also see that it produced a higher resolution stream network. Comparing the two, the drainage boundary has been impacted by the addition of the infrastructure. So Pete, take it away.
Okay, thank you, Laura. Just a little background before we dive into the demo about how we've gotten to where we are. We've done this once before too in Massachusetts. We did the Mystic River Basin. So this is our bookend watershed on the other side of Boston Harbor. We hope to kind of fill in the gap with the Charles at some point. Our entire focus now is on the Neponset, and a lot of work goes into kind of stitching together the data that you've given us and to clean it up. We use two key base maps, one being the DEM, the LiDAR data, to really give us a sense on elevation and gravity, for the storm drains as we're kind of doing the cleanup that we need to kind of hook everything together. And of course, the imagery is critical as well. We do use a handful of other base maps too, like the topographic map, for example, in certain cases. The cleanup goes into it, involves doing some splitting and editing vertices and snapping and creating of features, and we do all this in ArcGIS Pro, and a significant piece of the processing towards the end is the use of the ArcHydro data model. The Esri has a small team. They've been together for as long as Streamstats has been together, we've collaborated with them they basically have developed tools that we utilize to work through this process. Next slide. And so you've probably seen, observed on a few slides by now that we part of the processing after we've kind of done our cleanup of the storm drains and the inlets, making sure everything is snapped and oriented downstream, is we generate overland flow. And so this is really kind of one of the magic steps, of the process, where once you've got your inlets and your outlets and your storm drains, and you make sure everything is ready for input, you run this process and you get the overland flow, leaving the outlets, also entering inlets, including inlets that are inlets to culverts. And of course, on the other side of the culvert is the outlet. So sometimes the storm drain is just a simple one-line feature, which is a culvert going under a road. And so this overland flow gets generated from all of this. And through that, we get what is a geometric network, which is a traceable network from the headwaters through the storm drain network and then through the overland flow, ultimately to Boston Harbor in our final product for the outlet of the Neponset River. Okay, yep, next, Laura. So this is our what we have set up right now on our development site. Laura had mentioned the development site. This is an internal site. It is, available to everyone, but we don't make it public because it's a site where we're still in work. So usually we let our cooperators know about this site, and so that as we're getting to the point of publishing data, the cooperators can offer input. So this is our pilot area. It overlaps Medfield, a piece of Medfield, and a piece of Walpole. As you can see, it's kind of a headwater area of the entire Neponset River Basin, which is kind of a key to doing this. We work from headwaters downstream, so we're starting with the towns that are in the headwaters of the Neponset and working our way down eventually to the mouth down in Quincy. We've actually done quite a bit of processing for many of the headwater towns, not just this pilot area, but this pilot area we've taken all the way through from soup to nuts. So it's about a 4.5 square mile pilot area. You can see it in black. And again, it overlaps Walpole and Medfield and a very small sliver of Dover. Next. Okay, now we're going to run the narration here. So let's have at it. Can anybody hear this? Yeah.
No, we're not hearing any audio.
Oh dear. Okay. Let's see how that can be shared.
When you share, you have to click on the allow the audio. There's a box before you share something.
Ah, I see. Okay. Let me give that a whirl. I'll stop sharing for a brief moment and then share again.
Yeah, this sounds familiar. Yeah.
I learned that teaching classes.
Thank you.
So just to get you initiated, this is the opening window. When you first open Streamstats, there's a number of ways to find your location. One way is just kind of zoom in, you scrolling on your mouse. And so for example here, we're scrolling in. And as you scroll, you're going to see there's all these different Streamstats products. And the closer you get to your geographic area, this number reduces the number of products available in that rough window. So that's one way. A second way is by entering a latitude, longitude. I'm not going to demonstrate that at the moment. The third way is to enter a geographic name, a place. It could be a river, it could be a town, which is what we're going to do, and any other type of geographic name that shows up on a topographic map. So we're going to enter the town of Medfield, since that is the bulk of the area that the pilot area is in. And so you'll see Medfield pops up in a number of locations around the country, and we want this top one, Medfield in Norfolk County. You click on that, and a little window will pop up with some additional information about your your selection. We're going to X that out. And here now we're zoomed in enough where there's basically three options in the window. The rough window, I should say, because the Connecticut River Basin is not really in this particular window. It's a little bit off to the west, but that is a separate product, as is the Massachusetts statewide product, which is at 10-meter resolution. But the Neponset River Watershed product is at 1-meter resolution, and it has storm drains included. So we're going to be, this is what we're going to be showcasing. We select that, and the first thing you see is this hatchet area. This is an area around our pilot area. It's eventually going to be around the entire Neponset River watershed when we have the final product done. But yeah, this hatchet area basically means this is kind of the area where you cannot click points to get delineations. It just kind of defines the area. There's other ways we use the exclusion areas. For example, if in regular stream stats, if a river is dammed with altered flow, because Streamstats is primarily a flow statistic product, we want to make sure that we point out that, you know, on these dammed rivers, that the flow is not natural, that sort of thing. So there's different ways you can use the exclusion polygon. But for the storm drain products, so far we just have it around the actual study area, because we don't have flow stats yet set up for storm drain products. Okay, so one thing I want to point out is this zoom level down in the lower left, and as you zoom in, you're going to see additional information show up. So here you can actually see the catch basins, the storm drains show up, and as we zoom in a little further, you'll get to zoom level 15, and it automatically switches to imagery. This only happens for storm drain products because the imagery is more in line with the accuracy of the streams and storm drains that we're producing. You'll note here that the imagery we have is default imagery nationwide. I'd eventually like to get the imagery just set up primarily for the Massachusetts product, but that is something that is in the works. So okay, so what I'll do now is actually demonstrate how the delineations work, which are kind of the foundation of all this. This is what all the processing goes into to making this all work. So here's a location. And by the way, the other thing about the imagery is that you can zoom in closer to get a delineation than you can with some of the other base map options, which, by the way, are over here, and you can toggle from one to another. For us, we started with the National Geographic product, which you can't actually even see at this resolution. But yeah, there's a number of base map products that we can use. So we're now set up with the imagery. Okay, so what I'm going to do is I'm going to select a location on this stream and click here. And what's it doing now? It's going ahead and delineating a watershed. Now you'll see a couple of options over here. This ignore exclusion polygons is not very relevant to the storm drain products at the moment. But I'm going to also demonstrate the surface contributing basin only product in a moment after I do the delineation. I'll be doing it from the same click point. So we just wait to get the delineation here. It usually takes about a minute or so. Okay, so here is our delineation from that click point. I didn't point out earlier, but upstream, what you're seeing is a little subdivision that has a storm drain system going through it in this orange color, along with the catch basin. The storm drains are actually the the linear feature, and then the catch basins are the entry points into the storm drains, you know, the grades, and those are also illustrated here. So you have this system, makes its way into this river system, and on down to our click point. So this is the drainage area, which includes the storm drain area and the river area. The next thing you can do is just hit continue. And what we see now is regression-based scenarios, which is basically flow stats. We do not have that set up for any of our storm drain products yet because we are, although Washington DC is working on this, we are trying to come up with ways on getting flow statistics in urban storm drain areas. And you know, we have some ways that we're discussing on how to do that. Basically, regression-based flows are available in all statewide products, but like peak flows and low flows and that sort of thing. But we're still trying to work out how to work this out in urban areas. We're going to skip right down to the basin characteristics, and you're going to see a number of characteristics pop up. This is a development site, so we don't yet have this weeded down to what we have available at the moment, which is just drainage area. These other characteristics we plan on implementing, but that's only after we'll get the whole Neponset-wide product ready. So what you want to do is select drainage area and go to the bottom and say continue. If you click any of these other ones, you're going to get a warning message that they're not available yet. Okay, so let's just wait on this, and we have our report ready. You click on that, and it shows basically it's called, you know, it's a Streamstats report. You can enter whatever title you wish, along with comments. It shows the lat long of your click point and the delineation, and here's the drainage area. 0.08 square miles. So, so that's a report. You can, from there, you can actually go ahead and download the basin in a number of ways, including as a shapefile. In that shapefile will be an attribute table that at this stage will include the drainage area calculation. So you can download, or you can, or you can also print this page as a PDF, I believe. Okay, so you can do either or. So there you go. That's kind of soup to nuts use of Streamstats. I'm going to show a couple of more examples. So the first one, so what you do is, what I want to do here is clear the basin, but then also go to the same click point, and this time I'm going to click on surface contributing area only and go ahead and delineate again. Okay, now you can see here the delineation only gives you the area of delineation for the surface contributing area. It excludes the storm drain part of it. We find that this is going to be somewhat of importance to parse things out when it comes to coming up with flow statistic calculations somewhere down the road. So we have this implemented as well. And again, leading to hopefully a future robust flow statistic product for storm drain mapping. Okay, so one more demonstration I want to show is actually what happens when you delineate a watershed on a pipe system. So we're going to clear the basin one more time, and now I'm going to zoom in to the subdivision, and I am going to uncheck the surface contributing only, and go ahead and I'm going to click on a pipe location. So try to get it as accurate as possible. The way to do that is zoom in as much as possible. And I'm going to go ahead and click here on this pipe location. And here are the results of the click point on a pipe location. What we see here is that the delineation of the watershed is slightly upstream of the click point, and this, I use that term upstream loosely here because what's happening is that at the click point you're underground, you're in the pipe, and it only works with watershed delineation where it gets daylighted at the catch basin. So these catch basins are it's basically the contributing area to the catch basins. So picture the click point surfing underground up the pipe until it finds these catch basins in the nearby area, as well as the ones further upstream, and gives you a watershed. So this is clearly a different way of delineating watersheds using the pipe system. If there was streams coming in upstream from these storm drains, it would include that surface area as well. So often we have that where there's flow coming into the storm drains from upstream, natural flow. Okay, so that is the demonstration. Thank you.
All right, resharing my screen there again. Can everyone hear me okay?
Yes.
Yes.
Great. Right on. All right.
Okay, so I am in Streamstats.
Whoops, there we are. Go ahead, Pete. Take it away.
Okay, so yeah, so I just wanted to show like one other example here of a delineation. You can see that delineations in these suburban, urban areas can be pretty complex. Sometimes they you get multiple polygons that are disparate. It's all about how the storm drains are interacting with the surface flow. You're never going to see this type of thing in what I call regular stream stats, which is always going to be a singular watershed. In these urban areas, you are going to have, you know, the types of watersheds that we don't expect to see, the types of delineations. In this case, this was a delineation that we've done in the pilot area, and we did want to point out that we're getting, in some cases, delineations that are, if you look at on the left, there's the image where there's two locations that only have an immediate contributing area to the storm drain. I didn't see this a lot in the Mystic. I did see it a little bit. So there's there's a few different possibilities that could be playing out here. It's basically doing what it's supposed to do. But in these areas, these storm grates are not collecting a lot of water. And again, it could be for several reasons. One could be that the storm grates only collect flow when the flow is high, when there's a lot of flow coming through this area. Otherwise, it bypasses those storm grates and makes its way in the image on the right. It makes its way to the north. This area that's not being captured. Another possibility is you can see that these storm grates are placed right now in what looks to be driveways, and so is this a locational issue where the driveways are slightly upslope of the streets? That's that's the type of thing that we would have to look into, because if the storm grates are actually not exactly where they should be, and they actually belong down closer to the street, I'm thinking that maybe that would also allow for a singular polygon here that would fill in that gap. So yeah, we have seen some of this, and we're kind of looking into the various reasons why. But the tools are doing what they're supposed to do based on what the LiDAR is offering and what the location of the storm grates are offering. Okay, thank you. Next.
All right, so here's a simple timeline of where we are within this project and where we're going. So at present, as we glossed over a little bit, we're just wrapping up our data pre-processing steps, so integration, editing, and so forth. From there, we'll reconcile the boundaries, stitch them together, and process it seamlessly. Eventually, to wrap up the project in 2026, we hope to update you, as well as, spread the word of the new addition to Streamstats as far and wide as possible. And if you were unable to scan the QR code before for the development site, here's just one more opportunity. Again, we just ask that you don't share it with broadly with others, as it's preliminary and subject to change. Recall from Pete's presentation that, you can search for your location for your desired delineation, add in coordinates, or simply just zoom into the area. One more way to access Streamstats is either through the primary site on the right within that green QR code, and you can also access an informational project site on the left, and that will give you a little bit more of a resource center. So how-to guides, applications, batch processing, all of that is there to help you should you get stuck. Finally, just thank you so much for participating. Your data and feedback have made this project possible. Thank you for assisting us and supplying your data for this effort. If you ever happen to have any questions or would like more information, please send us an email anytime, and I'll throw it back to Anna.
Great. Thank you so much for that presentation. I think we have maybe a couple minutes for questions, if anyone has them, and I will stop this recording.